Can anyone please confirm?
Yes, Vijay. I can see.
Yeah. Please be in mute. I'm getting some sounds. Okay, fine. Okay. The last class just we have discussed what is big data, how data is getting generated, different types of data, how the sources of data from where it is getting generated, what is Hadoop, what are the sources, and Hadoop is for batch processing, difference between online processing and batch processing, why Hadoop going for batch processing, and difference between those two, and drawbacks of databases, Hadoop, why databases are not taken as a backend to Hadoop for storing its data because of some drawbacks of databases, and Hadoop advantages I was discussing, Hadoop job and Hadoop and Spark job market. Okay, I got some couple of queries before I go. So drawbacks of databases. So Hadoop provides two services. What are the two services provided by Hadoop? For storage and for processing. Storage and processing. Storing the data and processing the data. For storing the data, what we use? Yes, try to respond. HDFS, right? For processing.
Yes. MapReduce and Spark.
MapReduce Spark. Okay, so these are the services provided by Hadoop for storing and processing. Okay. If I take big data, huge data generation. If I take big data as a problem, you can say like Hadoop as the solution. Hadoop as the solution for this. If I take the big data as a concept, take Hadoop as the implementation. Okay, fine. So drawbacks means drawbacks of databases, very less storage, no parallel processing, as volume increasing, speed decreasing. Yes. Complexity increasing, speed decreasing. Yes. Hadoop advantages. These are the Hadoop advantages, right? Unlimited data storage, very high speed processing, can handle all by open source. Okay. So I've got some queries. Why databases like Oracle? Why databases like Oracle? Please be in mute. Why databases like Oracle can't support unlimited storage? Cannot support unlimited data storage. Database cannot store. Okay, cannot support unlimited data storage. Okay. For example, if I take databases, observe this databases and that max number of limits. Limit on max number of nodes. Databases and limit on max number of nodes. First one, like for example, Oracle. Can go with 256 slaves. It can go with max of 256 slaves or CPUs for storing its data. MySQL can go up to 54 slaves for storing its data. In real time, even for this databases like Oracle, can go with multiple slaves. And MySQL can go with 54 slaves. Third, for example, MySQL Express can go with 256 slaves. SQL Server, take DB2, can go with 256 slaves. But I cannot say these are unlimited data storage. Once the 256 slaves gets filled, they cannot support data further. But we have got some specialized databases like Teradata, used for data warehouse purpose. So it can go with 512 slaves. 512 slaves. And we have got like Netija, can go with 512 slaves. Vertica can go with 512 slaves. But Teradata and Netija, if you take Teradata and Netija, currently they are supporting, observe here, Teradata, Netija. They are supporting nearly 1024 slaves now. As of now, currently, they are supporting 1024 slaves for storing its data. Even though 1024 slaves, I cannot say it's a huge data storage. Unlimited data storage is not possible. Once they get filled, all the 1024 slaves, once they get filled, they cannot support data further, right? So none of these databases supporting huge store with unlimited data storage are processing. So none of these databases supporting unlimited data storage are processing. Unlimited. But Hadoop, there is no limit on the number of slaves for Hadoop. Yesterday I was saying like horizontally unlimited scalability. Horizontally unlimited scalability, right? So here Hadoop, there is no limit on the number of slaves that Hadoop can have. Yesterday I was just showing you like an example like Yahoo, when first time implemented Hadoop, went with 4,000 slaves for processing its, for storing its data, and currently Yahoo going with 12,000 slaves for storing its data. Facebook, when first time implemented Hadoop, Facebook when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently it's going with 42,000 slaves for storing its data. Okay, fine. So that is what Hadoop is proven in the market. Storage point of view, yesterday I was showing you processing point of view, the speed of Hadoop as compared to other technologies. Okay, fine. And what I'm going to discuss as part of this course, what are that? So we have got many components, storage and processing components for storage. Hadoop ecosystem component.
Vijay, how can you say Hadoop also using large number of storage, means large storage? So you are mentioning Facebook Hadoop 8,000 slaves. Now we are using the 42,000 slaves. How can you say like that?
So even you can see this, it's proven in the market. We can see this in the websites also. It's proven in the market. Even you can see in the various websites, Facebook or Hadoop, Facebook or Yahoo. When first time implemented, they will get this many. Now it's currently they are going with this many slaves for storing this data. Okay, this not only this example. Yesterday I was saying one example, right? Processing point of view, Yahoo has conducted a test to check the speed of various databases in the market. The speed if you have seen the databases in Hadoop, that just take minutes and seconds of time. That example also you can see in that. You just Google and check, you can see the speed of Hadoop and the speed of as compared to other technologies.
So Vijay, is there a limit
Yes,
of using slaves? Like you said, Facebook is currently using 42,000 slaves. So is there really a limit? So in Hadoop that it can use only 42,000 or 50,000, something like that? Or no, there cannot be
so you can
unlimited.
see unlimited scalability. Hadoop has got unlimited data storage is possible for Hadoop because horizontally unlimited. Horizontally, you can keep on adding the slaves. Unlimited number of slaves can be added. But there is a limit on these databases. They can go up to 256. Specialized databases, they can go up 512 or 1024. But even if 256 slaves, but once if you see these 256 slaves, once they get filled, the performance of the system degrades. If 256 slaves given, even if you're filling maximum slaves gets filled, just like your mobile phone, if like 128 GB is given for or 64 GB is given for your mobile phone, once you fill all the 64 GB, the performance of the phone degrades, right? Goes slowly. The same manner here also the system, the speed, it degrades. Hadoop ecosystem components. Next I'm going to discuss about Hadoop ecosystem components. We have got many storage and processing components for storing and processing data. So we have got storage and processing components for storing and processing the data. First, we have got like HDFS, as I was discussing, it's for storage. Hadoop distributed file system. Hadoop distributed file system. One second. HDFS. It's for storage. Next, we have got like MapReduce. I was saying like MapReduce is for processing. Processing the data. See, MapReduce is a kind of parallel execution model. So it's for parallel processing, and it's going to have got great speed. And within the MapReduce, we have got multiple phases like mapper phase, reducer phase. So how that execution happens, later we discuss. Next is Apache Pig. Apache Pig is also meant for processing, but the easiness or the easiness of Pig is it uses Pig Latin language. Pig uses what? Pig Latin language. Pig Latin language is a simple scripting language. 100 lines of Java code you can just write within 6 lines in Pig. That is what the easiness of Pig. If you are performing any task in Java which takes 100 lines, the same task you can just do in Pig with 6 lines. That is what very less coding. It's a scripting language. So we use Pig Latin language for performing this processing. It has got some built-in functionalities. Just we don't need to write any huge task directly. By using the built-in functionalities, you can perform the task in Pig, Apache Pig. So that's why the name Pig, it can process any kind of data, semi-structured, unstructured, or structured, any kind of data, it can process it. Apache Hive, very important component in the Hadoop, mostly used in each and every project. It is also meant for processing. It's a kind of data warehouse kind of environment in the Hadoop framework. DWH. It's a kind of data warehouse kind of environment in the Hadoop framework. Here we use a language called HQL, which is similar to SQL. Similar to SQL. Yes, very. Yes, Narendra. Please be in mute, Narendra.
What is SQL stands for here?
What is it?
What is
SQL.
HQL stands for in
Hive
the
query language. Hive
okay.
query language, which is similar to SQL. Hive query language, which is similar to SQL. Okay, fine. So here in Hive, if you see this previous MapReduce are big, we cannot create tables and we cannot perform querying. They are meant for processing. They can process the data, but you cannot perform some kind of querying as you do in SQL. So in Apache Hive, you are going to make the data structured, creating tables, and after that, you're going to perform some kind of querying on the data. Okay, fine. I'm getting sounds from someone. Fine, okay. See that if you have got some background noise, please be in mute. Otherwise, you can just communicate, interact with me. Otherwise, you can just present your queries in the chat panel. Okay. Next is scoop, which is also one of the important component of Hadoop. Scoop, that's nothing but SQL plus Hadoop. The first two characters of SQL and the last three characters. First two characters and the last three characters. SQOOP. Okay. This is for import and export operations. For importing and exporting data. What is that? For import or export. Importing data from different sources, different OLTPs. How Hadoop is going to get the data from where? We say that a scoop is a one of data ingestion tool. From where you are going to pull the data from? You are going to pull the data from different databases, OLTPs from different sources, bringing to a single environment like HDFS, where you are going to store it. And export, you can also, after processing, the result will be stored in HDFS. From there, if you want to export to any database, also can be done using scoop for importing or exporting. The processed results, if you want to display on your websites, so if you want to take back to your databases, just you can use scoop for exporting that. And apart from
Just one question, Vijay. So
yeah,
as you said, Apache Hive is like similar to SQL, and Scoop is also used to import and export. So can't we use SQL to import the data?
HQL you are saying?
Yes, from HQL.
Okay,
So
one
import
second.
the data.
One thing, scoop is not for processing. Scoop is not
Okay.
a Hive is for processing. Any kind of operations you can perform using Hive, but scoop is not a processing component. MapReduce,
Okay.
Pick and Hive are the processing components. Scoop is not a processing. It is just to bring the data and it's just to go import and just to export the data itself. Hive
So,
cannot
but
Hive cannot import the data, or Hive you cannot export the data from the Hive using Hive.
okay.
It's only for processing. Hive, we have got some kind of tables like internal tables, external tables. We have got some partition tables, non-partition tables are there. So the creation of processing the data and creating tables just like SQL and performing querying.
Okay. Okay.
Okay, fine.
Just like SQL in the sense, like Hive is HQL is belongs to the storage purpose, you can say.
HQL is for processing. HQL it's not for storage. Hive not for storage. It's for processing only.
As a SQL working as a SQL like that, no, that's why.
No, 1 second. SQL is also not a database. SQL is not a database. Once again, I say SQL. I'm talking like SQL is not a. SQL is structured query language. It is a language followed by all the databases. SQL structured query language a language which is followed by most of the databases. It's not a database, it's a language. It's a HQL is also a language. This for
Okay.
Pig Latin language, for Hive we use SQL language. But what I'm saying is HQL will be similar to SQL. What all that SQL operations you can do using HQL also you can perform those.
Okay, so
But in the
just
yeah, yes, go ahead.
so my understanding is, so whenever we start a project or something, so we need to use Scoop to get the data, and how we get the data is from HQL maybe, and process that from
No, no,
Hive.
one second. Let me diagrammatically I'll show you, make it clear. So for example, this is Hadoop. In the central, this is what Hadoop. This is storage. This is for processing. This is for storage. Hadoop is meant for storage and processing, right? For processing. So someone just was asking like, what is the importance of Hive in Hadoop? Means I got some OLTP database one, OLTP, database 2, database 3. From different branches, I want to pull the data from here, from here, from here, from here. So here I need to perform one scoop import operation. Here I need to perform one scoop import operation. Here also I need to perform the scoop import operation. 3 import operations I need to perform, and bringing the data and storing in where HDF. This is what HDFS. For storage, HDFS we are storing. After storing the data I want to, for example, any business logic. So I want to apply some logic on this, and I want to, you brought the entire data from all the branches. If you got some 30 branch, 10, 20 branches, you have brought the data into a scoop only used for import and export. Yes. Scoop only. Okay, I'll come back to your query. Yes, Narendra. Yes, okay, fine. I'll come back to this query. Once you pull the data from the different sources in HDFS, it gets stored. Huge data is supported in HDFS. On that data, I want to perform some operations. For example, what is the total? For example, Hyderabad branch, Pune branch, Mumbai branch, Chennai branch. I want to know what are the total salaries given for Hyderabad branch. So in there you are pulling the data from all the branches. In that data, all that is there. Now you are going to process the data based on your business logic. You are going to, okay, in that case you are just going for processing. You are going for MapReduce, Pig, Hive, Spark. These many components are given. Okay, MapReduce, Pig, Hive, and Spark. These are used for processing. Hive is for processing, Pig is for processing, Spark is for processing. Okay. After that, of processing the processed results, if you want to take to back to some any database again, who should take the data back again to the database? Scoop export this time. Scoop export operation. Okay, so scoop is for importing, scoop is for exporting. Scoop is not for any storage, scoop is not for any processing. But if you want, scoop can perform one thing. What is that? Before data coming to this HDFS, if you want some business logic to be applied, those things you can apply. I want only, for example, here in database one, you've got all the products, but I want only particular product details I want to pull, then you can pull it. Here, for example, if you want to filter some data, I want in this all the data is available of different cities. I want to filter only Hyderabad data and I want to store in HDFS. Those things can be done using Scoop. You want to filter the data here in database level itself. I need to filter and I need to bring it or merge the data and pull it into the database. Scoop can perform those things. But here Scoop acts as an import and export only, but it is not a kind of processing tool or storage tool. It's for import or that's why we are saying SQL plus Hadoop. SQL plus Hadoop means it is only for Scoop works only for a database and Hadoop only.
Yeah, it's clear perfectly. Yes.
Fine. Okay. But for example, 1 million records are there in DB1, but Scoop is importing all that. But my business logic is only on performing on a particular product P1 only. I want to bring only P1, but you have got 100 products, P1 to P100 products are there, millions of, but I want to pull only P1 records. I doesn't want to pull all the unnecessary. You can pull only those. Scoop can perform the operation, those things, bringing the data into the HDFS. In HDFS, you can see only P1 records. Another P1, you can directly process the data as per the project. Okay. Otherwise, if you want the entire data, you can bring the entire data and perform analysis on it. Right. See, and majorly with the demos in this, people generally ask, one second, let me make it clear one more point. Big data, Hadoop or whatever Spark, big data, and what is the difference between big data and data science, they ask. Big data is for data management. Data management, data storage and data processing. Data processing, both. Data science is for it's a blend of techniques. So everything deals with the data. Here, either in big data and data science, everything deals with the data. Here in data science, data has got experience, data has got future reference. Using data, you are going to perform some analysis. Using data or data science, you are going to perform some data analysis, data predictions, data classifications, data clustering, data recommendations. So it's a blend of techniques. It's a blend of techniques. The main technique that we see here in data science, machine learning. Okay, where we are going to, it's an approach where we are going to provide some data patterns. Based on the data patterns, we are making that a system to predict the things in the automated fashion. But here, data science is not for data management. It's for data analysis, predictions, classifications, clusterings. So here here data science, no, like here data management, here data analysis, predictions, classifications, cluster. Main technique that we use is machine learning. Coming back, NoSQL. Yesterday I was just briefing you like NoSQL, importance of NoSQL databases. Hadoop can perform batch processing. Hadoop integration with NoSQL can perform both batch plus Hadoop performs batch plus NoSQL with online OLTP or online processing. Okay, both can be performed if we integrate both Hadoop and NoSQL. So as compared to SQL, NoSQL databases has got great demand. The future databases will be like NoSQL databases. Even if you see the top 100, if you see that social media websites, you see everyone using NoSQL instead of SQL database. In the case of, for example, even NoSQL also can support that huge data. Like if you take that example of Cassandra, see,
So NoSQL is a database or it is a category, just maybe a classification?
NoSQL databases. There are NoSQL databases. We have got to know many categories are there in NoSQL also. If you take some, for example, key value store databases are there, key and value store databases, document store, columnar store, document store, graph store. So NoSQL database, they are categorized into key value, columnar, document store, graph store. Later when I discuss about this component, I'll be briefing you about these types of NoSQL databases, which category, like Cassandra comes in columnar store. MongoDB
NoSQL also language, huh? NoSQL also language.
NoSQL, yes, NoSQL databases we say. NoSQL, not only SQL we say. We have got not only SQL, we have got NoSQL databases. Fine. NoSQL means not only SQL. For random access and mainly NoSQL schemaless behavior. Schemaless behavior means what do you mean by schemaless behavior? If you take SQL database, Oracle, or if you take MySQL, these kind of databases, they need to maintain the schema. They need to
Rows
maintain
and
the
columns.
yes. For example, I've got some n number of records, rows, number of rows and number of columns. 1, 2 in the tabular structure, right? Here, number of columns 1, 2, 3. First record to the last record, the same number of columns to be maintained, right? But in NoSQL, my first record can have with 3 fields, second record with 5 fields, third record with 10 fields. Tomorrow I want to add 2 more fields for the third record only. I can add. So record to record, different number of fields can be maintained. That is main advantage. Schema-less behavior. In the case of this database SQL, every time you need to use alter command for altering the table. You want to add a table. If you want to add a new column, you need to keep on changing the table schema. But in NoSQL, record to record, any number of fields can be maintained. That is what the main advantage of NoSQL. So as part of our course, just I'm going to discuss one as a Hadoop and Spark developer, you need to have the idea about at least one NoSQL database. So as part of the course, I'm going to discuss HBase. HBase is one of the NoSQL database. This HBase is only for Hadoop. It works only for Hadoop. It's for Hadoop environment. It's a kind of NoSQL database which works only for Hadoop environment. But Cassandra is there. It's not only for Hadoop environment. It's for open applications. And for not only for Hadoop, but HBase only for Hadoop. Scoop is also only for Hadoop and SQL. Just I'm going to discuss about Yarn, yet another resource negotiator. Yet another resource negotiator. In the earlier versions of Hadoop, there were some little drawbacks. Everything got rectified in this Yarn from Hadoop 2 version onwards. We have got like Hadoop 0 version, Hadoop 1 version, Hadoop 2 version, Hadoop 3. But from Hadoop 2 onwards, we say it as yet another resource negotiator, Yarn. Multiple name nodes you can have, multiple masters. And Flume. Flume is also one of the data ingestion tool. This is used for streaming, capturing live streaming data. Capturing what? Live streaming data. So I'm going to give you the knowledge on streaming technologies also. Flume, it's a kind of for streaming data. What do you mean by streaming data? Anyone? Streaming, capturing live streaming data,
It's
capturing the data.
continuous inflow of data.
like data coming from Twitter or Facebook, like someone has commented on some status, so this is the live data, so we need to get that, maybe something like
Online
that.
polls,
Okay.
online polls maybe.
Yes. Yes. Polling, online polling. For example, if you take anything,
Broadcasting, like cricket match broadcasting.
for example, if you have downloaded a movie from a website, for example, F1, F1.mp4, the size is like 2 GB. Morning, the size of the file will be 2 GB, right? Afternoon, it will be 2 GB. Evening, 2 GB. After 2 days, if it will be 2 GB. Static. Means, for example, if you take example like CCTV webcam, or if you take the polls you have said, otherwise the Twitter messages you have seen, if anything. For example, it was 2 GB. Assume it was 2 GB. Morning 2 GB. Afternoon like 3 GB or 4 GB. Evening like 6 GB. After 2 days like 10 GB. Means what is this data? The data which keeps on generating, the data which keeps on incrementing, the data which keeps on generating, the data which keeps on incrementing. Such kind of data we call it as streaming data. So that data capturing and storing in the HDFS. So we have got streaming, capturing live streaming data. We have got a component like Flow. Kafka. Kafka is also has got a great importance in today's great boom in today's market. This is for advanced streaming component, advanced streaming and messaging system. Advanced streaming and messaging, plus also messaging also it can perform. Means messaging in the sense establishing connection between different distributed applications. And apart from this, Zookeeper. Zookeeper, the name itself saying it's a kind of security guard. Means most of if you observe, most of these Hadoop components will be like animal names. For all the animals, who is the security guard? Zookeeper. It's a component which controls and coordinates all the Hadoop component, all the other components. Okay. If you come to this Spark. Kafka is there, then yes, Flume not required. Spark. Very high speed processing, I can say. In-memory computation, very high speed in-memory computation. Generally, data stores in the disk and gets processed in the RAM, right? But in the case of Spark, data gets stored in the RAM, data gets processed within the RAM. That's why we say in-memory computing. In-memory computing. Lot of discussion on Spark.
Vijay, can you give an example for Kafka maybe? So how advanced streaming and messaging?
The thing is, in Flume, streaming data, there won't be any message delivery guarantee. There is no message delivery guarantee in Flume. Message is going to get delivered to that destination target or not. But in Kafka, message delivery guarantee will be there.
Okay. Any like real world example, like means like messages that are delivered to our phones or something like that, or what?
No, messaging in the sense means one thing. It's different. Uh, like if you got knowledge on JMS, Java Message Services. One second. Messaging in the sense means establishing connection between different applications. Messaging, for example, one application you did in Java, some inventory application. One application you have did in SAP, sales application. And one more finance application. One finance application using Oracle Finance. So 3 different applications in 3 different technologies here. So first application for sales developed in Java, assume. Second application for on sales, it is if it is done in Java, it's okay. But if it is done in SAP, communication between the applications cannot be possible, right? Communications between the applications. It is done in Java, it is done in SAP. If they are both are done in Java, then communication between them can be established. But here, so for that, we go for messaging systems like JMS, or they like Kafka.
Okay.
For establishing connection between the applications. In real time, if you see, Kafka will be in the centralized manner where anybody can read data and write data into it. Okay, means establishing connection between distributed different applications.
Okay, got it. Yes.
So Spark has got, we have got a lot of discussion on Spark, where Spark has got great boom, like Spark Core. We have got the data objects called as RTDs, resilient distributed data sets. We have got like Spark SQL, where we are going to perform some kind of querying in the Spark. We have got a concept of data frames. Spark streaming, microbatching we say. Spark streaming is nothing but microbatch. Microbatching, batch. Yesterday I was saying about batch. Today I was saying about microbatch using Spark streaming. Means for every batch means many, if you see many records getting, microbatch means for every 5 seconds I want an update. For every 10 seconds I want an update. This is what microbatch period. Batch means 2 hours or 10 hours means it's a batch. Lot of data gets generated, but 5 seconds, 10 seconds micro batching. Spark streaming, DS streams we say. We have got the concept of DS stream. Spark, very high speed processing, we call it as in-memory computation. Fine. Let me brief you about what I'm going to discuss as part of this course. Hadoop and Spark. Introduction, what is big data, what is Hadoop, need for Hadoop, sources, types, RDBMS, advantage, HDFS. First we are going to discuss components of HDFS. Next, after that, we go to MapReduce. Next, like MapReduce only. Next, Scoop, SQL plus Hadoop, like RDBMS database to HDFS, database to Hive, database to HBase, HBase to exporting data from NoSQL to SQL. HBase is a NoSQL to SQL, how we can export from NoSQL to database exporting. Okay, Hive to RDBMS, HDFS to RDBMS. Importing as transformations if you want to perform anything while importing or exporting. Vertical and horizontal merging, working with delimiters, aggregations, groupings, everything, incremental import, incremental loading, and how to define scoop jobs. Yarn, yet another resource negotiator. Speculative execution, speculative jobs, speculative tasks in Hadoop. Yarn architecture, Yarn components. Next, Apache Pig. Pig has got, okay, Pig has also, it's a very introduction to Pig advantages, it's Latin. evaluation functions in pick, diagnostic operators in pick, eval functions in pick. Hive. Hive also we have got a lot of discussion on Hive. It's an important component architecture. It's a meta store information tables, their types, working with unstructured XML data, JS1 data. See Hive processing unstructured data, XML data, JSON data, URL weblog data processing, unions, joins, multi-tables, file inserts, local files, HDFS, UDF, UDAF, UDTF. Okay, fine. Partitioning in Hive, dynamic partitioning, multi-column partitioning, bucketing in Hive, indexing in Hive, all those. Hive and HBase. Hive is the only component in Hadoop which can integrate with any NoSQL database. Hive can integrate with Spark. Hive can integrate with database. Hive can integrate with Cassandra. Hive can integrate with MongoDB, HBase. Hive and HBase integration I'll be showing you. This Hive and HBase integration means if I create a table in Hive, you can just it will be reflected in HBase. If I insert data in HBase, it will be reflected in the Hive. Means both integrations. Next, I was discussing about NoSQL. What is NoSQL? Types, advantages, keys, different types of NoSQL database, and HBase in depth of HBase. And next comes to Spark and Scala. Scala programming. First, Scala is a language. Spark is an execution model implemented by using Scala language or Python language or Java or R language. Mostly used as Scala. Scala is the native language of Spark. Scala basics, their types, their variable declarations, everything. Total Scala language is total. Before we go with Spark, Scala control structures, collections, transformations, everything we'll be discussing before we enter Scala functions. Before we go with Spark core programming, introduction to Spark, defining, comparing Spark with any other technology in the market, with Tej, with HANA, with MapReduce, Flink, all this. Flink dominated Spark. If you go back 4 years ago, 5 years ago, Flink dominated Spark in the earlier stages, but later Spark dominated with the new features, powerful features Spark has given. So we are not now, we cannot, very rarely we hear the word Flink, but Spark, mostly Spark is used. And data objects of Spark we call it as RTD computations directed. Okay, what we are going to RTD and Spark SQL concepts and deployment modes, local mode and cluster modes, and Spark applications. What are the various stages and tasks? Driver and Spark submission, Spark job submission. How we are going to submit the Spark jobs, creating jar and using it within the Eclipse IDE. I'm going to show you using IntelliJ IDE. I'm showing you, and using build tools like SBT build tool and Maven build tool. I'm going to show you, and I'll also give knowledge on the Spark and Cassandra. Okay. So I'll also be discussing a kind of project flow, how this entire flow is going, everything. So this is what in brief, in depth of all this Hadoop and Spark. You'll get the entire knowledge on this, right?
So maybe like can we parallelly touch base, like if not Scala, maybe with Python or Java, can we do it something on that, maybe for a practicing?
1 second. Scala has got the
And
command of both Java and Python. It's more flexible. Scala language. Scala means scalable.
okay,
Scalable language. So scale, that's why mostly for Spark Scala is preferred. Java is not at all preferred. If 100%, if I say the usage of Scala 50%, Python 90, 40%, if we say Java 5%. Very rarely this Java is used. Also R language also can be used, but not can be implemented using R language also. Fine. And Python, where can it be used? Means machine learning libraries are there. Spark also provides MLlib, Spark MLlib, machine learning libraries. So for that, mostly Python preferred.
So just out of context question maybe. So Scala is used like only in Hadoop or maybe in some other forms also in industry. Because why I want to know that, because I have spent most of my time developing working on some other tools. Now if I switch to this Scala, so why I'm thinking of Python to learn Python again, because I know Python can be used in other things also, but yeah. So concerned about Scala, I don't know about Scala. So if
So okay, I'll come back to your query. So there is one more query asked by Narendra Reddy. Yes, whatever you showed in the course index will be covered in all in the course, right? Yes, compulsory. Everything will be covered as part of this. You can ask me if anything is not covered. We'll be discussing all those. Actually, if this is an offer batch given for you. Actually, we used to go with Hadoop and Spark separate batches. It's a separate courses like, but we have combined together and we are offering the students in this pandemic. So that's why this Spark syllabus also you can just check it. Spark and Scala persistence options Python's here. If we come here, Spark and Scala transformations, Scala collections, control structures, functions, Spark core, already computations, here persistence options, Spark core computing, groupings, aggregations, various actions and transformations, and Spark SQL, Spark deployment mode, Spark application submissions, all these things. And Hadoop also, both in depth. What is the timeline for
Course duration.
post duration? 1.5, 3 months it takes. 1.5 months for Hadoop, 1.5 months for Spark. 45 hours, 45 hours, 90 hours it takes. But I'll try to complete if there is any possibility of having some bigger sessions. If every student are preferable for that bigger sessions on sometimes on Saturdays, sometimes on Sundays, so that I can complete a little bit earlier. Like it goes like if I get bigger sessions like 4 hours, 3 hours. Okay, during Saturdays or during Sundays when we want to see more kind of scenarios examples, we need to spend time there in Saturdays, Sundays. Then if I get, then I can complete within 2.5 months. Fine. Any other queries from your side? Any other? Yeah, fine. Tasks and assignments I'll be providing. Clear notes will be given for each and every topic. For the practicals, whatever we do. For the practicals, whatever I do, I'll just save it into one notepad file or this Word file, and I'll be forwarding you with clear comments. So you can just check it if you got any error anywhere. Okay? And more on this Hadoop. We'll be discussing more on this Hadoop on this Monday. Also, you can attend the session, everyone, at 6 p.m. same time, same link. For more on this Hadoop, I will be just demonstrating how exactly data getting stored, how exactly data getting processed within the Hadoop, how exactly data is getting stored, how exactly data is getting processed within the Hadoop environment. And there are some replications, fault tolerance, replication in Hadoop, fault tolerance in Hadoop, and the Hadoop architecture, everything. On Monday and Tuesday, we'll be discussing this. Any other?
We say map reducing and Hive both are processing we are using. Okay.
Yes.
So when we are going to the Hive, okay, when we are going to the map reduce, why? Because now both are processing now.
Yes, yes. Okay, 1 second. So both are meant for processing, MapReduce and Pig. So here we use Pig Latin language. Here Hive, Hive is a data warehouse. It uses SQL language. MapReduce, see MapReduce in the year 2013, 14, you see 12, 13, 14, 15, 16 also. It ran, it was a great demand on MapReduce. There was a great demand on MapReduce up to 2000. When Spark came into the market, the demand of MapReduce has decreased. because MapReduce, because majorly MapReduce, even if you see MapReduce implemented most of using Java language, but today like the usage of MapReduce has decreased a lot. So if you see in the architectural in this, MapReduce replaced with Spark now, very high speed processing. But still, I'm going to give you the knowledge on MapReduce. So why? Because in Hive, all this, if you see, MapReduce execution model is going to happen, but implementations, everything we are mostly now MapReduce as totally has got outdated now. Now totally everyone going with Spark.
If you
And the
use Spark,
Spark also, the
if you use
Spark
Spark,
also
then
processing, no?
Spark also,
It's processing, no?
yes, yes.
So, but what is the difference is both Hive and Spark? What exactly? Why? Because now both are processing only. When we are going to the Hive, what exactly particular time? Okay, this time we have to go to the Spark. So, what
So
exactly difference between both?
see here, Hive is a kind of data warehouse. It's a data warehouse kind of an environment, I said, right? Hive, most of the time, if Hive will be very much flexible in integrations. If Hive results, Hive and Tableau, Hive and Spark, Hive and NoSQL databases, means just now I showed you a diagram, right? The diagram went off. So first you are going to pull the data from different sources into HDFS. From HDFS, from HDFS, you have got for processing. You are asking like many tools are there.
Yes,
Uh,
yes.
yeah, said like MR, MapReduce, Pig, Hive,
Hive, Spark.
Spark. So from here, the process results again. If you want to take to database, so using scoop export, I said, right? The
Yes.
scoop export is going to be failed because huge data into the small database it cannot fit. So in that case, you are going to remove this database and you are going to bring NoSQL, right? Observe
Okay.
here, you asked where exactly this Hive can be used. Uh, Remove the database and keep NoSQL. But Hadoop
Okay.
data, if you want to bring into NoSQL, again I'll perform scoop export. Again scoop export, again it will fail because this time not because of storage, because scoop is only for Hadoop and SQL database, not for NoSQL. Scoop won't for NoSQL and Hadoop. So in that case, how to bring that Hadoop data to that NoSQL database? Then what comes
Hive,
Hive and
Hive, Hive,
yes,
Hive.
Hive and SQL integration. There comes yes. Even Hive and Tableau for visualizations. Okay, fine. That the Hive component is very much important in that case. From Hive you can integrate and you can bring the data to NoSQL. And for very high speed, we'll go for very high speed, where means companies where you can afford for huge bigger RAMs, they go for Spark. Still, otherwise they go for MapReduce processing. Means like Hive processing. Most of the time, MR is not used. Now Hive is mostly Hive and Spark mostly used. Pig also previously it is used a lot, but now but still it is used in the industry. Pig is
Here,
a,
Vijay, we are not using the Spark. Why we are not using the Spark? Based upon effect, company effects.
no. Why we are not using Spark today? Most of the time, if you see any interview, first they'll be testing you with Hadoop. Immediately they go for Spark. No. Spark is used in the industry. Spark is mostly used in the industry, but Spark means some small companies other they are going with the other things like Hive or mostly Hive they are going. But Spark means I want very high speed. Means I need to give big. For example, 1 TB data is there. 1 TB data is there. This data normally in Hadoop, if you take in Hadoop in Hive or a MapReduce, it will be stored in the disk. But in Spark, this 1 TB of data should be stored in the RAMs. Can you have 1 TB RAM? But if you take 10 TB RAM, 10 TB if the file size is 10 TB, so that's its huge RAM capacities to be maintained. So the even that maintaining these things also, that's the only thing. If you are able to afford it, then you can go with Spark. Means they are affording today, they are going with I want high speed, they are not getting to compromise with the speed, go for Spark. So if we discuss that components that we have seen here, Scoop is compulsory for import export operation. NoSQL database is compulsory. Yarn and Hive, these are the mostly used HDFS, mostly used components. So my concentration will be more on that components which are mostly used in the industry. Okay. Fine. So
Okay.
this is fine. Okay. On Monday also we will be seeing more on this Hadoop. How exactly? It's not like any duplication or replication. We'll be continuing from here, from where we stopped. Okay. Fine. We'll stop here for today. Meet on Monday again. Right?
Hello, sir.
Yes.
I was asking, is there any reference from where we can get big data like greater than 10 GB or 20 GB data for practical purposes?
Practical purpose, I'll be bigger data sets I'll be providing. I'll be saying, yeah, we have got some sites. Is I'll be saying that what are the sites? Download.
Sorry?
Yeah, we have got some sites for it,
Okay, okay,
from where you can download the data sets for practice
okay,
purpose.
okay. So we'll be providing those links.
Yes, yes.
Okay.
See, okay. The thing is, okay, whatever it is, you can just work with the data sets. Okay, fine. Any other queries? Fine. So I'll just stop here and we'll meet on Monday again with the continuation to this. Tomorrow there is no session. We'll meet on Monday. Fine.
Okay, Vijay.
Thank you, Vijay.
Thank you, Vijay.
Thank you, Vijay. Bye.